Hey guys, last time we have discussed about the behavior parameterization, or we can say the strategy design pattern. So I'm writing here the strategy design pattern. What we are talking inside it, we talk about the value parameterizations. Let's say I write it with the PM and we talk about the behavior parameterization in our last video. And what's next here? We have implemented the behavior parameterizations with different implementation, class-based implementation, anonymous class-based implementations, and then the lambda-based implementation. And this is the things we are covering, going to do in more details. So you have to tell how you are going to know what is the lambda expression. We clear these screens, we'll study about the lambda. You can define it as anonymous function. You can say it can be passed around and it can be concise. So I use just some keywords. We'll go into detail why it is anonymous. It means anonymous means it don't have any functions. That is the method. Pass around means you generally pass the values of different types, integer, strings, but you can pass the method as an argument. So it can be passed as argument to function. And concise means you don't need the boilerplate code. And so, for example, in order to previous to Java 8, you had to write the class-based implementations or the anonymous class in order to pass a methods to anywhere else. But here you can directly pass the methods. We will see the details. Let's take an example, and I am moving to the ID. So I already written the code, but let's say you write the comparator. You want to previous example we talk about the filtration of the car, but this time we're talking about this. We have to sort all our cars. You have given the cars, so you have to need a comparator, new comparators, and you want to sort integer dot compare based on which field we want to sort. We want to sort based on the car length, so get length or to dot get length, and your now your cars dot you have to call the sort methods and pass the comparators. It will sort your car. You want to probably print the cars. Sorted cars are and now pass all your cars. So definitely this method is doing well. It is going to sort the cars for you. So sorted cars are Maruti Suzuki Swift. This is the smallest car we have. Then the Altrus, then Baleno, and we continue to going on the sorted list. But what's the thing here? You want to pass the sorting behavior. Your intention is to pass the sorting behavior to this particular method, but you have to wrap it inside the comparator, right? So let's explain with the diagram how it does it look like. So let's rub this particular screen, and let's say you have methods that cars, and you want to sort it. You have to tell how to sort it, what mechanism to see it. So you need a mechanism for comparison mechanism you need to pass. Now let's say you are before Java 8. So how you are going to do? You are writing an either anonymous class or the class based implementation. So you write anonymous class in comparator. This is a box and it is an object to the operator, and inside that you write your sorting mechanism. So this is your sorting mechanism. Now when you come to greater than equal to j8, it means you can directly pass your sorting behavior, sorting mechanism. right? You don't need to wrap it, and you can directly pass this particular method. So that's what we are going to explain it right now, how we are going to do it. Let's say here we have this comparator. Instead of that, I will remove these comparators in this a while. For that, you want to create a comparators. You want to specify what arguments it will take and what implementation you have to call. This is equivalent to the above functions. You can directly go ahead and remove it. And you can see how precise and the concise that functions becomes. You can directly pass the functions. Let's try out if it is working. And definitely it again sorted in the same way. So it works. Let's understand what is the now the structure of your lambda expression. So you have seen this first sections is specifying the arguments separated by an arrow, and third part is the body, right? Which the expressions will be resolved. So arguments, separator, and the body. That is your lambda expression is. Now we are going to talk about the other two different styles of writing the lambda expressions. First is known as the expression style, and another is known as the block style. So let's move to another whiteboard again to explain you it in the details. So you are giving a particular string s. So this is argument. Then we know our body and then our implementations. So if I say that s dot length. So what this lambda expression is taking, it is taking a strings and returning its length. So this is the implementations. You can write lambda expression in this way. This style is known as the expression style. There is another style of writing this lambda expression the same way. I'm writing the, for example, here the string s, and you're passing, and here you are writing the curly braces, then you're returning what you're returning your s dot length, and you need to provide the semicolon in this particular style. So this is exactly you writing your code, and this is known as the block style. So mostly I prefer to write the code in the expression style, and whenever I reading the code, mostly I have seen this expression style. But when you have to do more than one single statement with this particular lambda expressions, definitely you're going to choose the block style expressions. Cool. Now take some example here of the lambda expressions. You have to tell which is the valid and which is not a valid lambda expression. First, a lambda expression is this and this. So is it valid? Answer is yes. Why? It is taking no arguments, and then the block style inside it is not doing anything. Next, our second thing, I wrote the array. So is it valid? Yes, it is valid. Why? It is taking no arguments and returning the array. Right. This is expression style, and this is our block style. Now the third is this, and return hello semicolon, and this, is it a valid? Yes, this is again a valid syntax, and this is your block style. Next is integer I, and you are doing, sorry, without this, return name plus I. Is this valid? Answer is no, this is not valid. Why it is not valid? This return statement does not comes in the expression style. So this is the expression style, or expression style has no return. Moving to the next one, string s, and here you write the Iron Man. Here you have the semicolon. Is this valid? Again, this is not valid because this is the block style. And in case of the block style, this is executed as the code we generally write, and generally we never write this kind of string without doing any operations, either the assignment or the return you need to do. Cool. I think so far so good. I'm removing the clearing the screens. Let's move to another topic here. So thing is how to use your lambda expressions. Hmm. So lambda expression has a concept of functional interface. What is the functional interface? Functional interface is an interface which has exactly one abstract function. And if it has exactly one abstract function, for example, let's take a look an example here. So in the last time we have implemented an here car predicate, and it has only one abstract function, so that is not being implemented. And whenever you define the lambda, it means you are providing the implementation to that. So whenever you're using the lambda expressions, the argument where you're passing, so it must be a functional interface. So let's take an example here. We have just seen implemented another example here, the comparator. So let's better look at the comparator. And in case of the comparator, you have find this is the abstract methods that whenever you passing your x method, so this is the abstract method that you have to implement. Again, you can have the runnable as another example here. So let's say runnable java.lang, and this class also has this abstract method run. So it can also, this is also, there is annotation, you can see that this is a functional interface. So I can use the corresponding lambda corresponding to that. So this signature will be validated. What you have to do, going to do in this particular case, let's say I want to write some code here. Sorry, I lost my keyboard here. Let me, yeah. So here we can see the runnable, and runnable of some runnable does not have a particular type. So you can have the R, and here you have some definition, and then you use the here the block style and system dot r dot println hello world. Now the signature of this particular methods is exactly satisfying the conditions of the runnable interface. So it takes no arguments, returns no values. That exactly we are doing in our lambda expression. Cool. So I hope so far so good. We can take another example of actioner, listener, callable. These are the some things you can again refer to. Now what we are going to study next, we want to use, I want to show you some examples. So last time we have discussed about the predicate. We have seen an example of the predicate here. And here I have written some other pattern for the consumer. Control and consumer in the Java. What is the consumer in the Java? That it accepts something and then process it. And there is a functions as well. function in Java, it takes something and transform it something. So we are going to take two different examples to satisfy these conditions. So I have written say consumer process. So how's the implementations? It is taking list of arguments and a consumer. That consumer can anything that consume that particular content, and then we apply that particular consumer to accept. What exactly I want to do? I have a let's say list of string, and here I have the strings. Here's not as list. Here empty strings. Here I have Azaji. Here I have Yadav. And before that I have this other empty string. And I want to print just the non-empty strings. So what I am going to do, I am calling my consumer functions, which is returning me the list of again the string, and this will be stored in the result. And here the consumer process. Consumer process, but I pass the strings, and instead of returning an implementations here for checking the completed strings, looping throughout it, I will just pass a lambda expression. What this lambda expression does, it is taking as an argument, and if s dot is empty, if it is not empty, string s, and why is it an error? Oh, your consumer process is not doing anything. Cool. No matter. Okay, we cannot pass here the lambda expression which is returning anything. We just want to print it. Let's say dot println, and what we want to print, we want to print our s. Right. So consumer is like something like we take an argument and then do the print. It does not require a semicolon, and it does not return a value, so it cannot be stored in the result here. So let's say this is the consumer and we want to run it. So these are not being printed. Interesting. I think let me figure out what I did wrong, because here we didn't wrote the s. It is we are returning the empty. Let's run it again. So we have printed here empty Sajay and then other. Cool. And then we want to have the map records, another functions which map records, which takes one type of argument and returns it to the other. For example, here we want the length of its strings. What we want to map records, we pass again the strings. Here we pass the s and return the s dot length, and this will be stored in the list of integer list, and here, and we want to print that particular list. System dot out dot println, and this is the list. Just you see, we pass the lambda expression for the transformations, and based on the transformation, we store the result. So it returns the list of length of its string. So first is 0, second 4, 0, and the 5. So I hope that particular session will